Hey, good afternoon, Applied GD&T students. This is a quick video that I wanted to put up to introduce the final project and to maybe give a brief overview of it. I will be making an announcement to the class right after this video with more details, and of course you can go on to the Canvas site to get all the details for it. But let's get started with the final project. So this semester, I've decided that the final exam for this class is going to be a final project. So there will not be a multiple choice final exam for this course. There will only be a final project, okay? And the final project, I'm going to go right down to it right now, right here, is going to basically be composed of three different parts. Okay, so here's the final project right here. There are three parts in it. There's a pulley bracket, a shift lever support, and a spacer problem. Okay, so these are the three problems. Let's look at the project description to get more detail about this. Okay, so I'm just going to read along and kind of explain things here. So what you're going to be doing is you're going to be completing the following engineering drawings: pulley bracket, shift lever support, and spacer. Those are the three drawings. Completing the following engineering drawings, adding the necessary dimensions and tolerances as specified below. Okay. After completing little typo. After completing and adding the dimensions and tolerances to each drawing, you're going to complete the drawing questions. So each one of these drawings will then also have drawing questions, okay? So the instructions for all of these drawings are to apply the dimensions and tolerancing according to the ASME Y14.5-2018 standard. This is the standard that we were following in our textbook, okay? Include only dimensions required for the geometric dimensioning and tolerancing. That means basic dimensions and size tolerances and things like that. So you're not going to be fully dimensioning the drawings. You're only going to be adding the drawings, you're only going to be adding the dimensions that are necessary for the GD&T. Don't forget to include all necessary basic dimensions. Include all necessary and relevant drawing notes pertaining to GD&T, okay? Now, this is an important thing. Because you're going to be adding these dimensions and tolerances by hand, right, you must make sure that your dimensions and notes are clear, legible, and easy to read for me, okay? You're going to submit these files, right, or images, depending on how you do it, and those images and files must also be clear, legible, and undistorted, okay? So that means you got to take a good picture with your phone. Notes. The drawings, that is the GD&T dimensions and notes, are to be added by hand, okay? Do not use CAD for completing the drawings. So some of you may be thinking, well, I know AutoCAD, or I know Inventor, or I know Fusion, whatever. Can I do these with CAD? No, not really. You're not given all the dimensions that you need to replicate the drawings in CAD. And oftentimes, for example, AutoCAD and Fusion don't have all the necessary geometric dimensioning and tolerancing tools for you to use, the commands and so on and so forth. So it really is not going to be advantageous, efficient, save you any time to do these drawings in CAD, okay? And the last thing it says here, and this is kind of a suggestion, a strong suggestion. Since you're going to be doing this by hand, you really have to take this point of view that you're going to be first doing rough drafts. Okay, so you're going to be printing out the drawings, and then you're going to be doing rough drafts of this, adding the dimensions and tolerancing, maybe changing things, erasing things, scratching things out. When you submit the drawing for the grade, I want that to be clear, legible, and easy to read, neat. So that means you're going to have to print it again and add or make a final copy of that, okay? So this is important. I don't want to see messy, ugly, kind of drawings with a lot of scratches on them, a lot of erasures and stuff, you can print out multiple drawings, and you can do multiple drawings by hand as you get better and know what you're doing. Okay, so print one copy of each drawing and complete as rough drafts. And once you have worked out solutions and your answers are to your satisfaction, print and complete the final copy of each drawing. Okay. Now I'm going to be very hard on this because that's important. So I'm going to your drawings that you apply by hand must follow the ASME White 14.5 standard. Okay, so just be aware of that. Now let's look at each one of these drawings. The pulley bracket, when I click on this, it's going to go to the assignment, and this is what the pulley bracket is. So this is what I'm giving you, right? This is kind of the description of the drawing. The pulley bracket is the middle part, right? So you see over here you have the pulley, right? On the left-hand side you have the crankshaft, and then the pulley bracket, or what they call the coupling here, is the thing in the middle. All right. And so what you're going to do is listed right here, A through E. All right. Now, I'm not going to go through each one of these, right? You can read A through E. All right. Add dimensions and tolerancing by hand as described above to the pulley bracket drawing. So let's open up the pulley bracket drawing. So this is the drawing that I'm giving you. All right. There's the pulley bracket. So you can see that there's plenty of space here to add your dimensions, right? To make your calculations, to scratch out, to change things, right? So this is where your name goes, the date. This is the drawing that you're going to be turning in, right? This is what you're going to be turning in. Now, I made sure these are 8.5 by 11 sheets, so you should be able to print them easily on a printer, on a home printer, or a printer at the college. Remember, the college is open if you need to go and print drawings there. Okay, so let me close that. So that's the drawing. These are the things you need to add to it. All right, and then after you after you finish adding these GD&T features to the drawing, then you're going to complete the pulley bracket drawing questions. All right, so let me open that up. Here's the pulley bracket drawing questions. This is the assignment. All right, answer the questions in the document below. Calculations must show work for full credit. Work is shown in the space provided. Be neat and legible again, right? Because you're going to upload this as an image file or PDF file. So here are the questions. Oh, and by the way, each question is worth 2 points. So here's the questions. And they're basic questions about the work that you're doing. Okay, so for example, how many unique datum reference frames are there for this part? What are they? What is the virtual condition size of the 4 mounting holes? And then there's area for you to work, so on and so forth. Okay, so that's the pulley bracket drawing question. So let me go back to this. Okay, so for this assignment, for this part of the final project, the pulley bracket, you're going to be turning in 2 things. You're going to be turning in the completed pulley bracket drawing with all your dimensions and tolerances added to it neatly. And you're going to be turning in the pulley bracket drawing questions. Both of those are going to be submitted as either image files or PDF files, depending on what you want to do, right? Using your phone to take a picture or some scanner, something like that, all right? Making sure that it's legible, neat, and undistorted. All right, now let's go back. So that's the pulley bracket. There's the shift lever support. Again, here's the drawing that you're given for the shift lever. This has all the dimensions in it. Here's what you're going to be adding, so A through D. Here's the drawing that I'm giving you that you print and add your dimensions to. And then here is the shift lever support drawing questions. And you see it's the same idea. So for example, how many unique data references are there? What is the virtual condition size of the 5 clearance holes? if one of the 5 clearance holes is produced at 1095 millimeters, what would be the allowable positional tolerance on the hole? All right, so these are questions that you have done already in your application problems for the class, that you've already answered in quizzes. Okay, so this is all work that you're done. You're just doing this now in a more realistic, real world kind of application. All right. And finally, the spacer. There's the spacer drawing. Here are the directions for the dimensions and tolerances that you need to add to this. Here is the spacer drawing that you're going to print out and then write your dimensions on and then resubmit. And here are the spacer drawing questions. Okay. So, I think it's pretty straightforward. You're going to be completing 3 drawings. You're going to be answering 3 sets of questions based on those drawings, and that's going to be your final project. Okay? A couple other things just to finish up here. Scroll down here to the final project. Okay, so it's all listed here. You can see that was the description that I just went through. The pulley bracket, problem description, drawing questions, and drawing itself, drawing sheet is there. Same for the shift lever, problem description, drawing questions, and drawing sheet. And the spacer, problem description, drawing questions, and drawing sheet. In addition, if you want to see the whole thing in one document, then you can click on the final project here. This is everything in one document, including the questions at the end. Okay. That's for your own reference. You will be needing to calculate the tolerances, metric tolerances for 2 holes. So I also included here under reference material metric fits, hole basis clearance fits. All right, so these are the tables that you'll need to figure out the sizes for the holes and shafts, depending on what your requirements are or what you're given. And then finally, there is a GD&T workflow. Now this kind of is a little bit outside your needs. Some of you may find this helpful. This is just a workflow for how you can go through problems. I think this is probably a little bit much. This is more for going through a problem where you're deciding what, or drawing, I should say, a part where you're deciding what needs to be done to it as far as datums, datum references, tolerances, all that good stuff. So I don't think this is going to pertain very much to the work that you're going to be doing for the final project, but I felt like I should include it anyway, just to finish things off. Okay, so that is your final project for spring of 2021. Okay, now remember, this is worth 110 points, which is 10% of your final grade. Okay, and each, well, if I go down here, let's go to the course schedule and syllabus. So here we go here. Final exam, 110 points, which in this case is your final project. 110 points, so that's 10% of your final grade. Okay, so it's worth a lot of points, and you definitely should not wait until the last day to get started. All right, so the last thing I want to say is about the due dates. Okay, so all of these drawings, all of these questions for the final project are due May 18th, right? May 18th, May 18th, and May 18th. That is the Tuesday of final exams, okay? The final exam week. Now, I have it, I made the due date May 18th because, of course, I'm going to have to go through and grade all these, so I need time to get these done. Grades are due on Friday, so I kind of have to have a period of time, a couple days to go through these. But that gives you 18 days from today to get started on this. Okay? So you have 18 days to get started on this. All right? That's a lot of time. I don't want you to wait 17 days and then get started on this, because you will not have enough time to finish this, period. You won't. All right. So you need to get started as soon as possible. All right. That being said, the last chapter, chapter 12, is very important to this, because some of the topics that are discussed in chapter 12 are going to be used in the final project. So get chapter 12 done. Right? The homework, the application problems, and the quiz. All right? Get that done. Print out the work for this. All right? Print out the drawing sheets so that you have those, and then get started on it as soon as you can. Remember what I said. You get into the mindset that you're going to have to print out multiple copies of these drawings. Have one copy, the first copy as a rough draft. Work on that. Get your ideas out. Figure things out on that sheet. Then print it out again. Right? And do another draft, maybe a less rough draft, until you get to it where you have everything that you need on it. It's nice, clean, neat, and legible according to the ASME Y14.5 standards. Your dimensions are applied. Okay? So that's it. If you have any questions, please feel free to email me. If we need to have a video meeting, then that's fine. I'm sure I'll be talking to you more as the final project, as you start working on your final project, probably to remind you to print out this stuff and to get started and to really bother you. But it's very important that you get started on this as soon as possible. Okay? All right, that's it for today. So I will talk to you soon. Have a good day. Bye.